Hey, boys and girls, it's Mr. Mac from the Harker School. Today, we are going to be working on fractions as one whole. In prior videos that I've done, we talked about a fraction being a part over a whole, where the part is your numerator and your whole is your denominator. If you didn't get to see those yet and you're kind of confused, make sure you go and check out those videos as well. Today we're dealing with, like I said, fractions as one whole. So you're going to realize in this lesson, when we talk about fractions as one whole, we are talking about the numerator and the denominator being the same. Okay, so for an example here, it says there are 4 panes of glass in one window of Landon's classroom. Each pane of glass is 1/4 of the whole window. How many fourths equal one whole? Okay, so this is 1/4 and 1/4 and 1/4 and 1/4. When you have 4 of those fourths, sorry, that looks a little tough there, but if you have 4 of the fourths, that is equal to one whole window. When you have every piece that we have, every part, it makes up the entire whole. All right. So any fraction, if we're talking 3 out of 3 or 3 over 3, that is going to be equal to one whole because it is everything. So even if it was, let's do a weirder number, 7 out of 7, that is going to be equal to one whole because you have every part of the whole. 7 is the 7 parts, and 7 parts make the whole thing. So that's kind of what we're going to be talking about today. Anytime that your numerator and your denominator are the same thing, that is going to be equal to one whole. So let's take a look at our next page here, which gives other examples as well. Okay, so when we look at how many wholes are there in 3 over 1, there's 3 parts, okay, and then one whole is partitioned into one part. So when you say 3 parts and one of them makes the whole, that means that we have 1, 2, 3 wholes. Because remember, 1 is my whole, and we have 3 of those wholes, okay? So we could also say, 6 over 1, that is 6 parts, and one part makes a whole. Well, if we have 6 of them, then that means it's going to be equal to 6. Okay, so that's our big focus today, is understanding that when your denominator is a 1, whatever your numerator is going to be, that is how many of the ones you have. So even if I said 17 over 1, that means 1 makes up a whole, and we have 17 of those. So that's going to be equal to 17 wholes there. All right, so it's always important to take a look at these key concepts here. So let's take a look here. It says the numerator and denominator are the same, then the fraction is equal to 1, which is what we talked about earlier. And then if the denominator is 1, the fraction is equivalent to the whole number represented by the numerator. And that's kind of what we just went over here, where our denominator, the bottom number, was 1. So we know that the fraction is equal to whatever this numerator is, which I just rewrote here to be 17. All right, so let's look at this guided practice down here. It says write a fraction to represent the shaded part of each whole, right? So how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 that are shaded. Okay, and then when we look at how many total pieces there are 8 total pieces. Okay, so now if I had to say, well, what is 8/8 equal to? 8/8 would be equal to 1. Well, what does that mean? Well, that means that the whole figure is shaded in. 8 out of 8 pieces are shaded, so one whole figure has been shaded in. Okay, so now for this one, there are 1, 2, 3, 4 shaded parts, and there are 4 total parts. So again, even though this time they're in a set instead of a whole, it's still the same thing, that since the numerator and the denominator are equal, that means the whole thing is shaded in. Everything that we have is shaded in. All right, so I'm going to erase this. I'm going to move on to our next slide, where we're going to get a little bit of practice for the practice on these. Let's just make sure that we pay attention to my directions. I'm going to tell you when to pause this, and you're going to try to answer all of these on your own. Now, if you're like, I don't really quite get it yet, Mr. Mack, it's okay. All right. You don't have to, but this is a good chance for you to see what you're understanding and what you're learning about. Okay. So again, I'm going to say pause it now, and let's try 3 through 8. Pause it and try it. And then when you come back, which is now, I'm going to go over this, right? So the question says, write a fraction to represent the shaded part of each whole or set of wholes. How many are shaded? 4. How many total parts did I have? I had 4. Okay. And then the next one, how many are shaded? 2 are shaded. How many total pieces are there? 2. Same with this one. How many are shaded? 2. How many total parts are there? 2. These are the same idea, except this is the sets of wholes, and this is our whole. Okay, so 1, 2, 3, 4, 5, 6 are shaded in out of 6 total parts. This one, 1, 2, 3, 4, 5, 6, 7, 8 are shaded in. Okay, out of 8 total parts. Sorry, they look a little wild. And then 2, 4, 6, again, same thing. 8 are shaded in out of 8 total parts. So this 7 and 8 are the same, just like we said 4 and 5 were the same. Okay, so now we've got 9 through 14 where we get a little bit more of a challenge where it says write each whole number as a fraction. So same as before, I'm going to pause now, and I want you guys to give this one a try. Go ahead. And you're back, right? So we are writing 4 as a fraction. Well, the fastest way to do this one, anytime you're writing a whole number as a fraction, all of your denominators are all going to be 1. Okay, so I'm going to put them all as a 1 because, again, any whole number, denominator is 1, and then the whole becomes your numerator. So that would be a 4, this would be a 2, this would be a 6, a 1, an 8, and a 3. Okay, so again, that's something that you think about and makes sense. If our whole is 1 and we have 4 of the wholes, that's going to be equal to 4, period, as a regular number there. Okay, so we're going to move on to the next one, starting with number 15. 15, 16, 17, and 18, it says find the missing numerators and denominators, then circle the model that is not a fraction or for one whole. Okay, so multiple things you have to do here, right? So we're looking at denominator of 6. What is our numerator going to be, right? So we got to figure that out. Same with this one, 16. Denominator is 4. What's the numerator going to be? This one's missing both. So you're going to have to fill both of those in. And then this one, you're missing the denominator. You also need to figure out which one is not a fraction of a whole. So I'm going to say pause it and give it a shot. And then unpaused, here we go. There are 6 total pieces. You could have either said 5 or 1 in here, okay, because you're either saying 5 are shaded or 1 is not shaded. I'm okay either way. This one is also the only one that is not a fraction of a whole, okay? This one, 4 out of 4, 4 4/4. This one, again, all 3 out of 3 are shaded. And then this one, 2 out of 2 are shaded. All right, now for this one, number 19, it says write 3 different fractions that are equivalent to 1. Well, remember, any fraction where the numerator and the denominator are the same, they're equal to 1. So as long as these were the same, you're good. All right. So this could be 3 over 3, 4 over 4, 5 over 5. You can say 200 over 200, a billion over a billion. It doesn't matter which ones you pick as long as they are the same. All right. So hopefully this helped you to understand that when the numerator and denominator are the same, your fraction is equal to 1. And also when you have a denominator of 1, the numerator tells you how many wholes you have. All right. Good luck with this, guys, and talk to you soon.